Okay, so today is a storm day, so it's supposed to be quite windy, and it is actually. Right now it's very quiet in this area, so that's nice. I decided to go and test, first of all to get some walk, but also to go and test the new gear. So I have now the camera holder, so if I do swap, I get the camera out, and if I push it by, then it gets locked in. So you can't see the action, but like it's kind of a twist action. So I should have purchased this one from the beginning, but I was stupid. So merge, and yeah, so I'm now on my way to walk around the 3.5 kilometer track that I usually walk, and then in the afternoon I probably have to run about 5 kilometers if we get the food early. So we are waiting for the cat food. My traveling is going to be starting on Friday, so I have 7 days for my flight to leave. So very excited, very close. Work is starting to really not taste good because it's the last 5 days left at work. Then I'm gonna shut down everything and be gone for a month. Well, not a month, 3 weeks. Yeah, I'm at the moment thinking about the topics for today. I went and saw that the current content crop, which should be starting soon, is stuck between 2 topics. I wasn't supposed to film a video for it, so I'm just gonna be giving my thoughts on the 2 topics and posting this anyway. But I'm gonna be on holiday, so I won't be knowing anything about it, so we'll see what happens there. So the 2 topics at the moment are, let me pull up my notes. They are currently voting between platform road mapping, balancing feature requests, tech depth and strategic vision, and platform engineering for edge computing. And I noticed when I was doing rough outlining on what would I want to see from each topic that I had more topics about the edge computing, so I'm gonna talk about that after. So, how to balance platform engineering initiatives and between features, tech depth and strategic vision. From my point of view, technical depth is a depth. So if you're starting out and you have an early platform, you want to make sure features are your priority one, and preferably features that are used by the customers. Your number one challenge is going to be adoption. So you need to push the adoption high, and it needs to be like critical to get the adoption up from the early times, so you can start having customers that feed into your strategic vision. Then step 2 is to align that towards the strategic vision. So your technical depth and feature depth basically should be coming from the strategic vision. You don't want to develop anything extra during the early days, because everything extra is going to be technical depth until someone starts using it. So you want to develop specific solutions at the beginning, because that's how you get the users. And then you start getting complaints that I need this or that, and you start creating technical debt, usually. And you want to take a healthy amount of debt. So let's talk about like how we look at it from the point of view of you as a person. So most of us have between 20 to 30% of our wealth going to debt. So if you have an apartment or a mortgage, you have that much usually going towards your debt. If you have a student loan, it probably is less at the beginning because you have other costs. But idea behind these is that like you can have about 1/4 of a work reserved for debt, and that's what you're gonna have to take most of the time. So most of the time you're making 75% ready stuff and leaving the 25% for future. And the big thing is you can't take debt forever, but you also can't start paying it too early. So you can start paying it too early, but then you don't get the adoption, which means that you have a problem of your technical debt is actually paying off your technical debt is actually creating more debt in the feature side. So what you want to do is you want to keep a healthy amount of debt, which is usually about 25%. So that's why, for example, unit testing and so on, the standard is 80% coverage. You want to keep a certain amount of debt around because it keeps you fast. And the strategic vision, you want to align towards that. So if you know something is limiting you from reaching that strategic vision due to the debt being high, then you need to start figuring out how do you pay that. But the other thing is, if you're doing platform engineering correct, you can actually have an inner source system also in use, so other people can commit back to you. So that way you can get the rest of the organization also help out on paying your debt, because you have quite a high debt because you are the support function. But if you can get the business areas to pay their debt or invest on their development, you can have a lower debt for yourself. And that gives you capability of taking on even more debt on your side. So that's kind of my views on it. There is no magical golden triangle around it. It always depends on your business. But I would look at it, where is the money? How do you find the money? And how do you get more money? Because that defines most of the time your funding also, so your initiative doesn't stop early. So yeah, I hope I had somewhat of a correct idea. And easiest way to balance these things is to put it visible. So if you use platform engineering and you have the metrics visible in the portal, make your own metrics visible in the portal. Get your own backlog visible there. What needs to be developed, how are we developing, and what are we developing. And that should guide you and the rest of the organization to invest on that depth also. And maybe getting someone to do some of the work for you if they have time. So the other side of the thing is how do we actually calculate the edge cloud. So how do you platform engineer in edge cloud? And it's not simple. The problem is you're having a system that has that has no internet connectivity most of the time. So well, that's changing also now due to Starlink, but usually didn't have a good internet connection because it was expensive. So the ideology behind it was that the cargo ship was, for example, cargo ship. That's an easiest way to think about it. It leaves from China towards Europe. It takes a month or 3 months to run through the whole process. So you're gonna have to put that 3 months thinking that there is no way to update the system. It's an edge system running on a faraway device. And you won't know when it's online, you don't know when you're gonna take an update, and you have no idea when can you actually do things to it. So it's a very challenging environment to develop. If you do unplug, the next time you're gonna update it might be 3 months from now or 3 years from now. Because if it breaks, someone needs to go there physically and reinstall thing or do something, and that might be really slow unless it's a critical system. And if it's a critical system, you might cause a big accident, because these systems are usually edge, like it says edge cloud, so somewhere in the edge of your devices. So we've noticed that oftentimes you need to do, first of all, very solid platform engineering from the point of view that like you have to have a continuous delivery, but so that the system itself pulls the updates, does the changes, and works independently. So anytime a system that requires or has been on the sea, for example, we have actually one customer that has this. So if the system has been on the sea for 3 months, any of them can come in and pull the changes and do the updates. And it can be backwards compatible, so pulling it backwards, or it can be so that it pulls like one version at a time and updates it. It depends on how you configure it and how you want it to be running. And it requires proper GitOps practices. It requires really good testing. It requires clear release process and guidance documentation. And if something goes wrong, how do you fix this in the C? It also requires very robust systems and understanding of those systems. So, not that simple. And yeah. So 65,000 euros for a cabin. So that's interesting. So yeah. So platform engineering requires in those environments also the fact that like the devices, the hardware itself changes underneath depending on what is prepared for that chip or comparable, because you're not going to have a homogeneous environment in edge clouding, because it depends on money oftentimes. So you need to really know what's happening there so you can calculate and tune your deployment model based on that. And oftentimes it requires quite a lot of figuring out, like what does it look like, how do we want it to deploy, and what resources does it have, which you usually would manage in Terraform in cloud, but in edge systems you don't really have that luxury. So again, it's a pool-based system and it's based on whatever is available, unless you're delivering the hardware yourself there. But even then, like, you probably won't have the same hardware, which is why on-premises is so difficult. That's why we created virtualization in time and containers, but they don't solve the outside interfaces and challenges. So thinking around the fact that like, what's the common architecture that we can have? What are the critical paths? What's the additional components? What do we need and why? And yeah, that generates basically the thinking around why edge computing. How do you do that in platform engineering model? Then we get into the like, how do you work as a platform engineering team? And that gets really complicated because like, again, it's not just a software team involved anymore, because we get the whole managing different sites and possibly different like devices in different locations, and it becomes complicated. How do you collaborate? Where is the limit? Like, what's the platform engineering team doing? And what are the engineers doing, like themselves? What's the local devices doing? And like, do you need local IT guys? Do you need specialists to install it? What are deployment patterns that you can provide? it gets, you have to map these out and align what's the responsibility. So, yeah, that's today. So thank you.